Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x minus 2 squared times 2x plus 1 cubed. The first thing to do is find the domain. F of x equals x minus 2, a polynomial, squared, times 2x plus 1, a polynomial, cubed. A polynomial raised to a power is a polynomial times another polynomial. It's still a polynomial. The domain of a polynomial is all real numbers. So the domain will be all real numbers are negative infinity to positive infinity. The next thing to do is find all critical numbers. We will take the first derivative, f prime of x equals, f of x is a product of two functions. The derivative will involve the product rule. Derivative of the first, its power rule. Bring down the power, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside. Times the second left alone, plus the first left alone, times the derivative of the second, a power rule. Bring down the power, leave the inside alone, subtract 1 from the power, multiply by the derivative of the inside to complete the chain rule. We will want to fully factor the first derivative. For the first term, we can collect together the constants. There's a 2 and there's a 1. 2 times 1 is 2. Times x minus 2 times 2x plus 1 cubed, plus the second term. We can put together the constants. Everything's multiplied, so you can multiply in any order. 3 times 2 is a 6. We can put that out front. We have x minus 2 squared times 2x plus 1 squared. We can now factor out a common factor of 2, as well as x minus 2 to the lowest power. It's to the first power and to the second power. We can factor it out to the first power. And a 2x plus 1 to the lowest power, we have it to the power of 3 and power of 2. And factor out the lowest, which is the power of 2. If we take all of this out, it takes away the 2, the x minus 2, and 2 of the 3 powers, and it will leave behind a 2x plus 1 for the first term. For the second term, we take out a 2. It'll leave behind a 3. 1 power of x minus 2 and 2 powers of 2x plus 1. So it'll leave behind a 3 and an x minus 2. The 3 will be multiplying the quantity of x minus 2, so it'll be in parentheses. Inside of the square brackets, we will want to simplify that so we can distribute the 3 in here. So we have 2x plus 1 plus 3x minus 6 so we have 2 times x minus 2 times 2x plus 1 squared. And then inside of the square brackets, which I will turn into parentheses now, we can combine together the 2x and the 3x, which will be 5x, and then the 1 and the minus 6, which will be a negative 5, which has a common factor of 5. We can factor the 5 out. We'll move all the way to the front with the 2 to make a 10. Since everything's multiplied and the order of multiplication doesn't matter, and factoring out a 5 will leave behind an x minus 1. We can now set the numerator and the denominator equal to 0. We only have a numerator here. Solve for all x's that make it true. Since we have factors, each factor can equal 0. This will lead to x equals 2 for the x minus 2. 2x plus 1 equals 0. Subtract 1 from both sides, divide both sides by 2, negative 1/2. And then an x equals 1 for the x minus 1 factor. Now we check to see which of these are in the domain. The domain is all real numbers. These are each real numbers. They're all critical numbers, therefore, and we keep them all. We will now draw a domain line, a line representing the domain. It has no left end because of the negative infinity, no right end because of the positive infinity. But we can break this up with these critical numbers in order. The lowest one is -1/2, and then 1, and then 2. We can now pick test numbers in each of the intervals that have been created by the critical numbers. We have 4 intervals here. Negative infinity to -1/2, we can choose -10. -1/2 to +1, we can choose 0. 1 to 2, there are no integers in there, but we can choose 1.5 or 3/2. And then from 2 to positive infinity, we can choose +10. We can test the trend by plugging the test values into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative, so it's best to plug into the fully factored version. A couple things to notice here. The 10 is positive, so it will not affect the sign. And then the 2x plus 1 is squared, and therefore will always be positive and will not affect the sign. So only the x minus 2 and the x minus 1 will matter. So really, we just plug into these two. If we plug -10 in there, -10 minus 2 is a negative, and then -10 minus 1 is also a negative. A negative times a negative is a positive. This will have a positive first derivative in this interval, which corresponds to an increasing trend. Plugging 0 in, the only two that matter. 0 minus 2 is negative. 0 minus 1 is negative. Negative times negative is positive. We have a positive first derivative. This corresponds to an increasing trend. We can now plug 3/2 in. 3/2 is greater than 1 and less than 2. So 3/2 minus 2 will be a negative. 3/2 minus 1 will be a positive. A negative times a positive is a negative. So we have a negative first derivative, which corresponds to a decreasing trend. And then plugging 10 in to the only two that matter. 10 minus 2 is positive. 10 minus 1 is positive. Positive times positive is positive. There's a positive first derivative in this interval, which corresponds to an increasing trend. So we have an increasing trend happening from negative infinity up to -1/2. Union, it's happening again from -1/2 up to +1. We cannot put those together because -1/2 is not included. It has a round bracket on the -1/2. And then union one more interval from 2 to positive infinity. So it's increasing most of the time here. We do have an interval of decreasing trend. It's occurring on the interval from 1 to 2. At the critical number of -1/2, we have the trend increasing and still increasing. The -1/2 was a critical number. The trend is not changing. It came from the numerator. That will make it be a plateau. So we will have a plateau happening at an x-coordinate of -1/2 and a y-coordinate that can be found by plugging the -1/2 back into the original function. So f of -1/2 will give us the y-coordinate. That will be -1/2 minus 2 squared, and then 2 times a -1/2 plus 1 cubed. Well, 2 times a -1/2, the 2's can cancel, and -1 plus 1 is 0, and that'll be 0 cubed, and then times the rest of it. So the entire thing will be 0. So that plateau will have a y-coordinate of 0. Right at the critical number of 1, we have the trend changing from increasing to decreasing, and that means that 1 will be a relative maximum, an x-coordinate of 1. It'll have a corresponding y-coordinate, which can be found by plugging the 1 into the original function, this will give the y-coordinate. It will be 1 minus 2 squared times 2 times 1 plus 1 quantity cubed. 1 minus 2 is a negative 1 squared. 2 times 1 is 2 plus 1 is a 3 cubed. Negative 1 squared is positive 1 times 3 cubed, which is a 27, so that'll come out to a 27. And then right at the critical number of 2, we have a trend change from decreasing to increasing. That'll make 2 a relative min. It has an x-coordinate of 2, and it has a corresponding y-coordinate, which can be found by plugging 2 into the original function. And that'll be the y-coordinate. And that'll be 2 minus 2 squared times 2 times 2 plus 1, and then quantity cubed. Well, nicely, 2 minus 2 here is a 0, and a 0 squared 0 times the rest will be a 0, so that will be a 0. We have a relative min at 2 comma 0. And this will be the results for the intervals of increase and decrease, as well as the plateau, the relative max, and the relative min for this function over its entire domain.